All right, welcome to the after work video. We're gonna start where I left off. So I will share my second screen and I will do it right. There we go. Okay, so yep, all I was doing really nice and easy. Unfortunately, kind of mindless. Like, I don't know, I think you're generally not really learning anything unless it does take some effort. And this feels for the most part kind of effortless to me, just reading the documentation here and typing it in. So it's kind of a bad sign, but it definitely does feel a bit effortful for me to kind of read it out loud and be more clear and verbose with what I'm doing. So that's a good sign for sure. So let's keep going. On the PE routers, configure a policy to export the BGP routes into OSPF. So I think we already did that. Yep, so I see where the policy is. It's right here. I don't think we applied it yet, though. Let's take a look at that. So we'll do a pipe match. Yep, so it doesn't look like it's applied, but hopefully we'll do that later. So this is, oh, nope, we finished this. Let's see if this is finished as well. Oops, so I'll search for RSVP. So yep, this is done as, oh, so that's RSVP. Let's see if the MPLS configuration is done. It is. Okay, so now it's time for the BRF routing instance configuration, because I believe I did. Well, let's just verify that MPLS has been set up on all of them. It has been set up on PE1. So let's verify PE2, and then the rest. You can see my cron job went off. Perfect. Show configuration protocols, and we're verifying MPLS. All right, looks good on PE2. Let's verify the P router. Okay, so this is where I left off. Let's start from here on router P, enable MPLS. Oh, my shoulders are all tensed. Oh, I gotta relax. All right, so let's see here. Show. Oops, so yep, I committed that. So I believe, nope, we still got another step to go. These MPLS, because they say to do a show route and to do all these verification commands, but they say to do that before it's all the way set up. So I don't know what they're thinking, but I was thinking just now, hey, we can do those commands, but that's not the case because we don't have family MPLS enabled on all of the appropriate interfaces. We can do those commands anyway, just so that we can see that, oh, sure enough, we're getting output back saying that there's a problem, but I know what the problem is. But yeah, let's because it's important to get familiar with that, of course, because that's what I'm going to be seeing during the exam. So yep, label switch path not found or no route installed. Could not build command string. Let's take a look at the first command too. I skipped that one. Oops. And I missed one of the commands. Okay, so yep, the first command looks good. So I'm not sure why I can't build the, you know why I can't build the command string? Because they gave me the verification command for the second one. So if I want to see it for the first PE, provider edge device, I've got to look it up by the label switch path name on the first PE, which is 2-PE2. Oh, but even then, it looks like I've got some sort of issue where it could not build the command string, even though we can see that it is PE2, and I did list that correctly. So yeah, I think it can't show it because this label switch path hasn't been created yet. It is configured, but there is no actual label switch path because it wasn't able to build it. Yeah, it wasn't able to install the route, so we can't use that command yet. But let's keep going and try to see if this command will work. So we do have output associated with this command here, even though we are specifying. Okay, so that theory is out of the water. We do have actual formation of the MPLS LSP, but it's in state down, and it can't detect where it's from because, of course, we're missing configuration still. So I'm not sure what's going on with this command. Let's question mark it out. So name of LSP tunnel associated with entries. So that's going to be 2-PE2. So I think maybe it's just because it's down is why. So this will start to work again. I think that same command will work as expected once the LSP is up. All right, so let's do this final step. That will bring the LSP up. I gotta calm down again. My shoulders are rising. Okay. So set interfaces GE001 family MPLS. Okay, so yep, this is good to go. All right. I guess it's a good sign that I have trouble doing this on the weekends because it's a good sign that it is difficult enough. Because that's of course a big concern of mine. There's no point in wasting my time doing something like this that isn't exactly pleasurable if I'm not going to get anything out of it. Of course, I'm always willing to delay gratification to have some tasks that I don't enjoy be prioritized over tasks I do enjoy, knowing that if I do the task that I don't enjoy, I can eventually have things available to me that I enjoy more than things I have available to me now. A great example of that is completing some sort of educational program, because you may not like being in the classroom, you may not like doing homework, but you will like the opportunities you get after you graduate, which is what I'm doing right now. It's just autodidactical. So we should have, actually we're not going to have any LSPs up still because we're forming it all the way over to PE1. So we're not going to have anything up. Another thing to know about LSPs is they are unidirectional. So we'll actually, our ultimate goal is to have two LSPs up. One from PE1 to PE2, and then the other one from PE2 to PE1, because we can't just have a single LSP and have it communicate bidirectionally. Typically, LSPs are bundled with the same path, but you can of course have one LSP take one path through the network and then say anything responding back, I want to go through a different path. But let's take a look at what we got here. Okay, so yeah, we can see it's still down because it goes all the way to PE. So it doesn't matter that the PE1 and the PE are configured because the final destination is not configured yet. Okay, so let's take a look at that command now. I can just do it on here. It's going to be for a different LSP because remember LSPs are unidirectional, but that is okay. The end goal is for them both to come up anyway. Oops, so it looks like it's still down. I'm kind of surprised that, okay, yeah. So it just takes it a while to come on down. Let's take a look at each time I entered this command. So the first time I entered it manually, so I've entered it manually here, it was still down. Then I did the pipe refresh. So it looks like the first two times it wasn't able to learn where it came from, but then it learned that, but it was still down. And then this P didn't have the star. So lots of things going on. We got the P with the star. The first thing that happened is it populated this column with the from. Second thing that happened, we can see it looks like the state changed to up. At the same time, the P got a star. So I'm not sure exactly what's going on here. It looks like even more things happened after that. The style changed to 1FF, the label in. So it looks like it actually got more. Oh, okay. So never mind. It's got yeah. So here's the banner refresh. So it's going to have three sections: ingress LSP, egress LSP, transit LSP. So that's really important to understand. So this is an ingress LSP, which is interesting. I would think you would have one for an egress LSP as well. I'm really shocked that it has one LSP and that's an ingress LSP. I would think that it would have an ingress and an egress LSP. So I wonder if something's actually going wrong. Okay. So yep, it was just slow to the ball game here. So we can see. Let me highlight this again, and let me highlight it so it's clear that yeah. So it's clear that it's starting there, and it's clear that it's ending there because we got the next banner. So we can see. Yep. Now we've got an ingress, and that's to PE1, which again I'm pretty shocked. Oh no. That makes sense. That makes sense. So let's look at our topology. So no, that doesn't make sense. Because you would think that the ingress LSP, the one that's coming in this way, would be the LSP name to PE2 because it's coming in ingress to PE2 from PE1. So I'm really surprised that the ingress LSP is named to PE1 and the egress LSP that I would think going this way is to PE2. That really surprises me. Okay, so let's think about that some more. So this is the ingress LSP. So I would think that the to field here would be a route on locally configured on this device. Let's take a look. Oops, and it's not behaving here. There we go. Okay, so nope, it's not locally learned. It's learned through OSPF via its left-facing interface. So obviously we know that and let me print this out one more time. So clearly we know that the ingress LSP is going what would appear to be egress. It's really not clear to me what the perspective is for these terms ingress and egress. Thinking of it from the perspective of the port here, I would think that these would be flipped and you would have the information here for the ingress going to this here, going to that there, up. You would have this information here for ingress, and then this information here for egress because the two is there. I guess one thing I think it's important for me to kind of change my thinking a bit and not really think about it in terms of here and really think of it more in terms of the loopback because that's the kind of address this is. So let's do a show route on that address. Yeah, and we can see that this is the loopback address. So let's try thinking about it from the vantage point of the loopback address. Okay, so from the vantage point of the loopback address, in my opinion, it still wouldn't. Yeah, it still doesn't make sense to have this information listed as ingress LSP to PE1. I would still think that if it were from the loopback here and then going out to PE1, you would have that be an egress LSP. So really interesting terminology. So I think what I'm going to do is do a Google search here and see if anyone else has this confusion that I have. So backwards terminology. So INET 0 is always a good sign. Let's try naming. All right, so let's go with that INET 0 resource. And let's see if there's a way to better understand these terms ingress and egress. Okay, so when an RSVP signaled LSP needs to be set up, the ingress LSR label switch router computes the path the LSP should take. This path is computed using information that is stored inside the Traffic Engineering Database, or TED. Information inside the TED is provided by an IGP's traffic engineering extensions. These traffic engineering extensions can be provided by OSPF or ISIS. Okay, that's kind of leaving a bit to be desired for me, at least. The RSVP path message travels from the ingress LSR downstream to the egress LSR. But yeah, I don't understand the information here. It'd be great if I could get a show MPLS. Yeah, so here we go. So I think I've got a few of them. So let's start with so after an LSP is signaled, there are two easy ways to find out what the content of the ERO is. You can issue a show MPLS LSP name, and that's just filtering. So this is the command we issue. And look for the computed ERO. Let's see if that shows up here. Okay, so I don't see it here, but that's because they have the extensive knob toggle. So let's do that. Type match ERO. Oops, and I did the wrong command. Okay, so here's the computed ERO. Looks like it's in columns, so that filtering isn't going to work. So yeah, so the information, the actual ERO, computed ERO, I think is right here. Additionally, you can issue a show RSVP session name extensive and look for the explicit route information. Let's do that. Okay, we don't need to, we're only going to have one session, so we don't need to filter that down. Okay, so let's look for explicit routes. And I wonder if there's a typo in here. Let's see exactly if that's what's there or if they are missing an I. Oh, nope, that is how it's gonna show up. Okay, so yeah, nothing wrong with that. Sometimes they, are one character too long, so they'll just take away a character like that. I mean, it's pretty clear that they are meaning to say explicit, so I think that's a good way to abbreviate things. See if we can find that just in the cloud of info here. Okay, I saw it. Here it is, explicit route. So this information will match what was shown up here. Yep, it looks like it. Well, let's see if it does. So let's see if this matches. Okay, so here's the computed ERO. So from what I understood reading that, and granted I didn't read it super carefully, but the computed ERO is going to match the explicit route. Okay, and it does. We've got these extra values S here, but that's because they are strict. So if they were loose, they would be L. So you get more information from that first command, which is show MPLS LSP extension. You get to learn whether it is a loose or a strict path. if you do show RSVP session, you get the explicit route, which is in many ways similar to the computed ERO. And in fact, ERO probably stands for explicit route something, but you don't get the information that tells you whether or not it is loose or strict in terms of hops, unless you do the MPLS command, show MPLS LSP extensive. Okay, so let's get a definition for ERO. I'm guessing it's stands for explicit route. Yeah, but I'm not sure what the O stands for. Explicit route object. Okay. As soon as the computations for an individual LSP are completed, the calculated path is written down in a list called ERO, explicit route object. The ERO is a list of all the links that the LSP should traverse. This list is then put into an RSVP path message, and this RSVP path message is used to signal the LSP. Let's take a look at those RSP path messages. I'm kind of tempted to just read every word in that INET 0 and to in fact go back through every topic and just like find a way to search the INET blog and read that. But for now, let's just look at the what was it called? The ERO, so the explicit route object, which will be added to an RSVP path message. Let's try to find the RSVP path message. So here we've got a hello, but we can filter out for RSVP using the fancy right click, and we can do apply selected as filter. So now we're only looking at RSVPs. So we've got hello messages. I don't see any path objects though. And that's probably because the paths have already been established. So I'm gonna tear it down and recommit. Okay, so we should get a path message now because I tore down the path. Oh my. So we got active messages. We got all sorts of things going on here. So this says path error message. So yeah, I think we're getting path messages. It's just we're tearing down the so here we get a tear message. So it's tearing down the path, so we get path error messages. But if we roll back to rollback, I'm sure we'll just get plain old path messages. Oh, yeah, it takes a while. Yeah, I don't think it's up yet. Let's see. So show MPLS LSP. Yep, it's still down. So we're gonna get that path message shortly. Here we go. Now we got it. So let's see if it's still down. Nope, it's up now. So yep, this is everything we're gonna need to look at. So I will stop the capture. Okay, and we'll go back through and see the path messages. So unfortunately, it's not labeled super well. Like I don't see, well, I mean, it's Wireshark. It is labeled super well. And look at all this, but it's not matching what it says in the INET 0, where you're going to get an RSVP path message. So I'm not sure what they mean by RSVP path message and what that shows up as in Wireshark. So we get a message type here. So let's do a filter as that. Let's just prepare it. And then we'll do and selected. So, oops, so message equals 3. So let's just filter out for RSVP.message. Okay, so now we're only going to have, oops, but it looks like, yeah, it looks like they all have message types. So we've got to choose which message type we want. So we've got bundle messages, we've got path error messages, we've got all kinds of messages. It'd be nice if I knew what type of message they were talking about, because I don't see any path messages. Let's do a Google search. Well, let's just keep looking through here. Yeah, I don't see any path messages. So if I could figure out what ID this is, let's try a filter field reference. So we've got a 404, unfortunately. Let's try a Wikipedia page. So the Wireshark wiki is maintained by the community. The page you are about to load might be wonderful, incomplete, wrong, or non-existent. Proceed to the wiki, yes. So I did find a way to be a part of the Wireshark community. It was a while ago I did that, but I am a part of this community, and I do have a page that I worked on. My goal was to try to make my work more visible. So I did add to the OSPF page, but unfortunately, it just turned out to be kind of a lot to take on, and it's kind of not something I had put into my study habits. It probably is a really good thing for me to do, but unfortunately, I I haven't been contributing very much to this. So yeah, I think most of this configuration leaves a lot to be desired, because it's really not been the kind of the main focus of the team developing Wireshark. And then I kind of fell short of the reason why I signed up to be a editor on this wiki. But I can always add to this. I just don't think it's super important right now for me. Definitely important for other people though, because yeah, here's the state of the thing. But yeah, it's so easy, low hanging fruit. If anyone is watching, I think I found it just by like creating a login, and like it told me how to send an email and you get approval. So like this is really low hanging fruit. First of all, it's yeah, well, this is nice because it shows you the acronym where it comes from. Um, but a brief description of RSVP, easy. Brief history, easy. Like this is all just set up for you to knock down and put on your resume and say, hey, look, I contributed to the Wireshark official documentation. That's really going to make you very appear to be very valuable to somebody. And again, I have done this in the past. I just added this um, brief description of OSPF and kind of went into detail with the designated router process, but I unfortunately did not invest a lot of time in that. All right, so I don't see any codes, unfortunately, so I don't think, well, this might be good because I've got the aha. So yeah, this looks perfect. This is exactly what I need, I think. So let's search for a path. Here we go. So path type, path message. Here we go. So we just need to do rsvp.path, and then we'll get all of the path messages. So I can remember that. So rsvp.path. Aha, so we've got 5 RSVP messages. Let's take a look at them. Its info is component messages dissected. It's kind of no wonder I got thrown a bit off guard. Yeah, and we can see it's bundle message. I don't see anything about path message. So we can see. Oh, I see. So it's a bundle message. There's kind of 2 messages in one. There's a header, and then there's a message within that, which is interesting to me. But the path really deeply buried within the information here, the segment for RSVP. Here's the segment, then we've got the packet, then we've got the frame. So it says frame here. So this is the frame header. It says frame here, but you'll notice that's because the whole thing is a frame. So when I click frame, it's going to highlight the whole thing. When I click this, though, this is the frame header. So it's going to start with the first bit, IP header, and then the segment. So let's see here. So we've got path message. So let's go back to the write-up. And this list is put into a RSVP path message, and this RSVP path message is used to signal the LSP. So let's find that list. It should be in this. Aha, so we found it. Explicit route right here. Do a filter for it. Yep, and now we've got 3. Okay, and I hate to do this because I've only got like 15 minutes left, but I'm going to pause and be back in a minute. All right, so that was definitely the right decision, and I'm back. It really didn't take any time at all. So I think we're done looking at that. So let's go ahead, and we've got, yeah. So I think things are kind of making sense. I'll definitely link this to or include this in my notes for this video. So this is going to be number 4 on this topic. And this is a great topic because it's covering a lot of the other topics on the exam. So I get kind of a nice overview into everything instead of just being stranded on a topic that doesn't have to do with anything else. So let's continue on. Okay, so we've got the LSPs up now, I believe, both of them. Yep, so we've got an ingress and an egress LSP up. They're not making a lot of sense to me because I would think that the ingress would be the one to router 2, and then the egress would be the one to router 1. Just thinking of it as moving this way versus moving that way, and then kind of from the perspective of leaving an interface, even the loopback interface, I would think leaving like this would be something called ingress. But I guess if you think of it in terms of the MPLS table, you would have the LSP yeah, I don't know. I think how I'm thinking of it in terms of interfaces is a flawed way to think about it. I know I had a lot of trouble understanding ingress versus egress when it came to routing policies, and the reason I had trouble understanding that is because I was not thinking of it from the perspective of the routing table. So that might be the source of my confusion for this as well. But unfortunately, it still hasn't clicked for me. So let's continue on. Okay, so next is the VRF routing instance. On the PE routers, configure a routing instance for the VPN and specify the VRF instance type. Add the fast Ethernet and LO0.1. Where did that come from? Customer-facing interfaces. Configure the VPN instance of OSPF and include the BGP to OSPF export policy. So here's where I think it's going to start breaking down, because it was clearly built on a house of cards. We don't have LO0.1 anywhere in this. You can very clearly see it. It's saying to configure unit 0 on all the loopback interfaces. There's no place in the instructions here where it said to configure this sort of interface. So it's definitely built on a house of cards, and you know, that's just a simple typo. There's also going to be a lot of issues where they just don't understand how to set up this sort of config. But I have a pretty good handle on it now because of my studying for 961. So let's get some error messages and figure out how to get it to work. So we'll start on PE1. And I can open up PE2 as well, side by side. Yeah, because we're going to need to do both of those anyway. There we go. Okay, so let's configure the VRF routing instance, which is a layer 3 VPN. VRFs are layer 3 VPNs. Yeah, one thing that's kind of cool about, well, when it comes to understanding language, I think one thing that might have helped a lot of people understand, well, I don't know. What I was going to just say just now is one thing I like about the coronavirus, which is you're already kind of off on a bad foot if you start your sentence that way. But I was just going to say how it might have taught people, you know, more about language, more about math. Hopefully people understand more about what exponential growth means because of it. And then hopefully people understand more about how you can have certain kinds of terms, like coronavirus talks about the kind, you know, it's like saying human, like I'm a human. SARS-CoV-2 is like saying, you know, my name is Graham, I'm a type of human. And then COVID-19 is like saying, you know, like teaching you networking, like that's what you get from me. So it's kind of what I was going to say is that to me there are some positives, but I think the negatives far outweigh any positives, so that's really not a valid statement. Okay, so we've got Yep, so we've got that. So let's do a show pipe compare. Okay, so the other thing I find really interesting is that they are adding a loopback interface to this. That's not something I would think um, you would do. But as I said, let's just get the error messages and go from there. Yeah, so already you can see we've got really serious issues. And of course, oh, okay, well, let me not get ahead of myself. This is something I've complained about before, not worth a downvote, but they're giving things out of order because if they want you to use this command, that presumes that you have committed the configuration already, because otherwise you'd either not have to use this keyword or you in fact could not use that keyword, or else you get, I will show you what you will get if it will allow me to. Sometimes it's not cool about that. So yeah, it doesn't recognize this. You can certainly do that command without that, but that's not what the instructions say. Another option you can do is just throw a run in front of it. So you've got two options if you haven't committed the config yet, and that's to take that configuration command out, or you can do a run show configuration. Um, but you'll notice a difference here, and this is really important to understand if you work on Junipers and really any device with a candidate and an active config. So when you just do a show here, you're looking at the candidate configuration, but when you do a run show configuration, you're looking at the active configuration. So I have not committed yet. I did commit, but it did not go through successfully. It failed. So I've got this configuration in my candidate configuration, but it won't be in my active configuration until that commit succeeds. So you can see I have nothing in there now because my attempt to commit it had failed. And that's just because I didn't do the next step, which is to set up the route distinguisher. So let's do that. Okay, so let's do a show routing instances, VPN-A. There we go. Now we've got the route distinguisher in there. And you'll notice we're using the syntax where you use the ASN. You can also use a IPv4 address. God damn it. Okay, so unfortunately, we've got a error here that says only loopback interface is supported under VRF routing instances in Triton mode. So I'm pretty sure I wasn't in Triton mode. That's why I was kind of upset there for a minute, because I'm pretty sure this takes it out of Triton mode, but you do need a license. Let's do a no on here, and then a show pipe display set, and then save this configuration. Okay, and I think I'm going to go a little bit longer today. I've got a delivery coming at 6, but they're just going to leave it at my door, so I'm going to give them an extra 5-10 minutes, cut the video, and go bring in my delivery. So, well, actually, what I can do is yeah, I'll just check my phone because I'm sure I'll get a message, and I'll see them deliver it. So, it looks like let's see here. They're gonna text me when the driver's here. So, yep, I'm gonna go a little bit longer today and finish this video once my delivery is out the door. So let's see here. We've got this configuration saved, so we can abort that configuration. So to do that, you do rollback 0, exit, and we need to put it in Triton mode, which to me means activating my license key, which I thought I already did, but I'll just try it again. Unfortunately, I've got to stop the share though, because I don't want my license key to just be public. And as I've mentioned many times before, you can get one yourself by contacting Juniper. It's a free key, but you will need to contact a Juniper representative. Okay, so the license was successfully added. Let's go back and add those commands in, and hopefully they will take now that I am in Triton, or now that I am no longer in Triton mode. I forget if I needed to be in Triton mode or if I could not be in Triton mode. So I will share screen 2 again. Okay, so now I will add those configurations back in, and I'll just type them out again. There, oh, there's my public key. Well, if you made it this far into the video, you all earned it. So, okay, well, and I've showed it multiple times before, but yeah, if you're a long-time watcher of this channel and you saw my key and you want to take a screenshot and type it out and it works for you, well, happy birthday to you. But I would say it's actually more, the safer route is just getting one yourself, because you never know if mine expires, anything like that, you're out of luck, and it's really is just a phone call away. It's better to have your own key that you know is reliable and available to you, and it's a free key. It's really no big deal. It's important to be able to. Sometimes I've found that the administrative steps when it comes to education are actually kind of the hardest part. So it's not necessarily taking the CCNA and memorizing all the questions that is difficult. It's making it to the test center on time, scheduling it properly, that sort of thing is often more valuable of a skill than memorizing, some basic fact about networking. Just demonstrating the fact that you have enough kind of coherence to do something complicated on your own is important to demonstrate. Okay, so let's see here. We've got so we've got the commands waiting to be re-entered. Okay, and this is going to be the interface facing the CE router, because this is the front door. It's what we're offering to the customer to send their traffic on, and then we're going to put it into a VRF, a VPN, which is a L3 VPN, so that it is protected from the public network. It's not just exposed out there. Okay, so now the route distinguisher. Okay, so we need a VRF import or VRF target. So hopefully, yep, okay, so that's in the instructions. So this is the part where it all breaks down. Uh, shoot. I'll just finish up what they have here, but I don't think we're going to get past this part here. Yeah, so even though we added those two lines, oh, now we've got even bigger problems. Okay, so it requires a pin configuration. So let's add that. But I think we'll still have this here popping up, even though we added the pin configuration. But let's move on to that and add that configuration in. Great, so let's see if it commits now. Nope, so we still got this. And it looks like we're out of extra errors. I mean, we can just finish the whole thing because I just want to make it very clear that the reason we're getting this is not because I missed some config or didn't follow some step in this example. It's that the example doesn't understand something really important to how to configure the Juniper devices. Either that or it's just using such an out-of-date OS that it just doesn't behave the same way anymore. Okay, so, but I'll prove that I did follow everything and this message still occurs. So the next step to doing that is setting up the provider tunnel. Okay, and then the final step is going to be the rendezvous point. Okay, so now it'll be evident that it's not that I skipped a step or didn't follow it exactly. It's that there is an issue with the documentation. I have submitted down votes for these before and reported this but I just kind of want to move on. So I will explain what the issue is. So to do that, let's take a look at the configuration as is. So it's going to be different in the candidate configuration than it is in the active configuration. But we can look at the candidate configuration. Don't need to look at the active. So here's the candidate configuration. We can see we've got a routing instance, and the routing instance has interfaces added to it. It has interface GE000, interface LO0. So that's good. We can see that GE001, that's not added to the interface. But we can see that it is added to OSPF, but this isn't added to OSPF. So they got it right for OSPF. You wouldn't be adding this to OSPF. But where they got it wrong is it does not belong here, because this, when you say set protocols RSVP, what you mean is set protocols RSVP. Well, let me be more clear here. So what you mean is in the MPLS.0 table, set the protocol. So let me clean it up, and then I'll show you how the table is different. So these do not belong in here. And if you were to apply these anywhere, you would have to apply them here. So protocols, RSVP, you put them there. And whether they're necessary in there or not, I am not sure. Same thing with LO00, and we know that's the case because it's added here and it's not added there. So, and by I mean it's not added there. We'll see that in a minute here, what I mean by it's not added there. Okay, so this commit will go through. Oops. So again, it can't be included in here. Oops. Oh, okay. Yeah, this is, when I was working on the 961, I submitted downvotes for just about everything. I was actually the Juniper internal documentation. They forgot to take me off one of the emails. I had a pretty big reputation over at Juniper. Oh man, what the heck? Oh, okay. Well, dang it. I think LO0 is not meant to be in there, actually. Yeah, I don't think LO0 needs to be in there. Oh, man. Oh, okay. This is messier than I thought. Yeah, this is way worse than I thought. I thought this was going to be pretty easy to fix. Yeah, I've got to add G001 to here if I want. Oh, you know what? I think I just made a typo. Yeah, I just made a typo. Yeah, because I deleted the, so let's see. Okay, so that was good. I'm gonna commit this, and then I think I'm gonna end there because it's 10 minutes past 6. I'm sure my groceries are delivered. I don't want them sitting out there for too long in the hot Texas sun. 10 minutes is probably too long. So we got a good commit. Before I end the video, I do want to make it clear what I was talking about. So if you have a interface added to a protocol, and you do that when it's not in a routing instance, because you can see set routing instances, the name of instance protocols, you have the ability to add an interface to a protocol there, OSPF, PIM, NVPN, anything you would want, BGP, you have the ability to do it under that hierarchy, but you can also just do it under the main hierarchy, set protocols, BGP, OSPF, whatever you want. So the difference between the two is what is appending. So when you do it in the routing instances, you're creating a custom routing instance here. So you're appending the name of the routing instance there. When you're not doing it in the routing instance, you've got it here. So you can't have overlap. You can't have GE000 belonging to a protocol for this kind of routing instance as well as this one. It's got to be in one or the other. That's what that message means. Okay, so hopefully that's clear enough. If you'd like a better explanation, let me know in the comments. But I got to bring in my order. So thanks for watching, and I'll see you in the next one.